Greetings from Sri Ramakrishna Engineering College, Coimbatore. Myself, Dr. Karuppuswamy, Professor and Head, Department of Mechanical Engineering, handling a course on measurements and metrology for UG students. As a part of that course, today let us see about one of the statistical process controlling method, the process capability. Let us consider a product, might be this stylus pen or our cell phone, whatever it. Every product is designed first and they will be manufactured using different resources. Each and every product will have multiple parts. The parts are designed and they will be assembled together to form a single product. Each and every product having different components, they are manufactured as per the specifications. For example, if a product is having 3 different components, each component will be manufactured as per the specific dimensions. There will be tolerance allowed on the each and every specification. After completing the processing, the parts are manufactured, all the parts are assembled together to make a product. Suppose let us consider if the parts are not produced as per the specifications, the product will not function as per our requirements, as per the customer requirements. Hence, it is essential to manufacture the parts of the product and they have to assembled as per the customer requirements or customer specifications. For that, we have to ensure that the process is under control. Based on that, today let us see about the statistical process control method. It is a process capability. What is a process capability? It is a tool we are using to assess the capability of the process, whether it will produce a quality parts as per the specification or not, whether the process is totally capable or not to have a specified product or part as per the design specification or customer specification. That is called a process capability of the process. Why we have to give a lot of importance in that? Because, for example, let us consider a small shaft having the diameter 50 millimeter, plus or minus 1 millimeter variation is allowed as per the requirement. We cannot make 50 mm diameter shafts exactly, so we are permitting little deviation plus or minus 1 millimeter on the size of the shaft. It is easier for the manufacturer to produce a shaft within 51 millimeter or 49 millimeter. So the parts between 49 millimeter to 51 millimeter will be accepted as per our specification. Suppose if the tolerance is not there, we need to produce the component exactly on 50 millimeter, which is not possible at all at economical considerations. So we have to ensure that the process is capable to produce the component as per the specifications, as in the case of example, the shaft diameter 50 millimeter is the nominal diameter plus or minus 1 millimeter. The process should capable of producing the shaft 49 millimeter to 51 millimeter. For example, every component, every shaft is produced by the particular process falls within the dimensional range of 49 to 51. We can say that the process is capable. We can produce the component as per the customer specification. Process capability measures how well a process produces output within the specified limits that we have discussed so far. It helps us to assess the consistency and quality of the products based on the process performance. It is widely used for manufacturing and quality control aspects. What are all the key concepts? We have already discussed about an example, a shaft having the diameter 50 millimeter plus or minus 1 millimeter. So this is an example we have taken. Let us consider this is a mean diameter of the shaft, that is 50 millimeter. It's a nominal diameter. Upper specification limit is 51 millimeter The lower specification limit is 49 millimeter. A component, let us say the first shaft having diameter 49.8, it falls here. Second component, second shaft, it's a 50.2 millimeter falls here. So if we plot all the sizes, what happened? The components will fall within this area, which is normally known as a normal curve. So this is how we have to see how the process is stable, if there is any possibilities for the process to get deviated from the required specifications. All these things we can refer. We want to calculate the process capability to assess the process ability, whether it will produce a quality product or not. For that we have to have a specification limits. Here we are having a nominal diameter of the shaft 50 millimeter. The specification is plus or minus 1 millimeter is given. Now we are having the specification. Next one, upper specification limit. We know that 51 millimeter is the upper specification limit. Then lower specification limit. So bottom level dimension 49 millimeter is the lower specification limit. We have to have a process mean. Here the nominal dimension is given. We can consider this as an ideal mean of the component 50 millimeter. Standard deviation, this we have to have it, or we have to calculate based on the actual dimensions of the component we have produced. So the process capability can be calculated based on the upper specification limit, lower specification limit, process mean, and also having the standard deviation. So we can calculate the process capability. So what is a process capability? That we have discussed so far. Process capability is a statistical process control technique where we are assessing the ability of the process to produce quality products as per the specification limit. Here two types of process capability is used. One is generally the process capability. Second one is process capability index adjusted for centering. What is the difference? CP index, what is the formula? CP equal to upper specification limit minus lower specification limit divided by 6 sigma. Let us consider the process already we have discussed. So this is a mean of the process having the dimension 50 millimeter. Here upper specification limit is 51 millimeter. Again lower specification limit is 49 millimeter. So in this case CP equal to upper specification limit 51, lower specification limit is 49, 6 sigma. Sigma value we have to have it for calculation. The sigma may be, for example, already calculated or expected variation is about, we can say 0.5, sigma equal to 0.5. Now we are having all the details including the sigma value. Now we can calculate the CP. It is a process capability. We can say that process capability is upper specification limit minus lower specification limit divided by the 6 sigma. So this is the formula we have applied here to measure the potential capability. Here we can say that potential capability, the meaning is what is the deviation that process will have, that is called a potential capability. We are not worrying about the location of the deviation in this case. In the potential means what is the deviation that a process is having right now. While calculating this, we can understand the difference between what is our specification, what is actual. This difference, the deviation between the actual capability and expected requirement. So these deviations we can calculate using the process capability. Based on this process capability in number, we cannot ensure that the process is within the control. There is a possibility that process may deviate from the required specifications. This deviation cannot be understood from the CP, process capability. So we should have the deviation from the central position. That is very important. For example, let us have, this is the width of the process capability. Let us say this is the variation. This variation may be located here, or the variation may be located here. Suppose if the variation is shifted here, there is a possibility for the out of specification product. Similarly, on the lower side, if the process is shifted, there is a possibility for the deviation. Suppose if the component is deviated, the component will be rejected here. If the component is moving towards this, the component will be subjected to rework. So these difficulties are there. Now we are calculating CPK. Now we are calculating the CPK index, upper specification limit minus lower specification limit divided by 6 sigma will give you process capability index, process capability. Now we have to calculate the process capability index. What is the difference? As I told in the previous case, this is the process capability. The entire spread is taken or considered. This is the mean value, lower specification limit, upper specification limit. While considering the process capability index, we are considering the centrality or location of the process, whether it is located centrally or is there any deviation from the central position. Suppose if the dimensions are in the deviated from the central position, there is a possibility for rework, there is a possibility for the rejections. So we have to avoid rework or rejections and ensure that the process is centrally located with respect to the specification, so that we can comfortably maintain our process and we can produce the quality products. While coming back to the CPK index, now the entire spread is divided into two. So upper specification limit, lower specification limit. So I have to consider left hand side half. Here it is a X bar, this is lower specification limit, this is upper specification limit. This is upper specification limit, this is lower specification limit, it is a mean dimension. Okay. We have to calculate the CPK, process capability index. For that, the formula is given as, we will calculate two values. We have to consider the minimum of these two values. Okay, how to calculate these two values? Let us consider the left hand side first half. So here maximum value is X bar, that is a mean dimension, minus lower specification limit divided by width of that, it is a 3 sigma, not 6 sigma, because we have divided into two halves. Then comma, now let us consider the right hand side. Here we can see the maximum dimension is upper specification limit minus X bar divided by 3 sigma. So now two values we have calculated by splitting the entire spread into two halves based on the average value, that is X bar or nominal value of the component. Now X bar minus lower specification limit divided by 3 sigma will give you one value. Then upper specification limit minus X bar divided by 3 sigma will give you another value. Now we have to consider minimum of these two values. Okay, that gives how the process is deviated from the centrality, from the central position. Let us consider the process is now here. Okay, it will give you one value. If the process is deviated from this place, let us take this is another point. Now consider point 1 and point 2. Point 1 is moved far away from the central position, there is a possibility that the process will deviate slowly towards the upper specification limit. There is a chance of moving beyond that at the earliest time. When you consider point 2, it is little closer to the central point when compared to the point 1. The process seems to be stable. Suppose if we are not taking any corrective action, there is a possibility that the point 2 will move towards left and it will reach lower specification limit and go beyond that. So to avoid that, we have to check what is the deviation from the central location. If you find the location deviates from the central position, we have to take corrective measures so that we can bring this process closer to central position to make the process stable. So this is how we have to calculate the process capability and the process capability index, two metrics. Based on that, we can assess whether the process is capable or not in producing the quality products as per the customer's specification. Now we have calculated process capability and process capability index. Which number is good, which number will represent the quality of the process or ability of the process. Here we can see that the CP value or CPK value is when the less than 1, the process is not capable. We can directly say that CP value we have calculated, CPK value we have calculated. If the calculated value is less than 1, it is purely indicates process is unstable. Any point of time or presently defective pieces will come, the process is not stable. Next one, when the CP value or CPK value is equal to 1, the process is just capable of producing the specification. In case of any mistake, immediately it will come out of the process and become unstable. When the CP or CPK is greater than 1 and 1.33, we can say the process is capable. The process will not produce any defects because the process is stable. But however, we have to observe whether this value is increasing for better stability or the value is decreasing, moving towards the out of process. Okay. So again there is another value, CPK or CP value is greater than 1, the process is excellent. That means the process is very stable. We have to maintain the process as it is, since it is excellent process and producing only the quality parts and products as per the customer specification. So this is how we have to analyze whether the process is within the control or not. Suppose if the process is not in control, we have to take the corrective measures to bring back the process into control. If the process is already in good control, we have to maintain the lot of parameters to the current condition so that it will continue in producing the quality products. For example, a manufacturing process produces a shaft, lower specification is 20 millimeter, upper specification is 30 millimeter, process mean is 25 millimeter, standard deviation is 1.5 millimeter. So when we represent in the graph, the process mean is 25 millimeter and upper specification limit is 30 millimeter, lower specification limit is 20 millimeter. The standard deviation is 0.5 millimeter, 1.5 millimeter. So CP calculation is CP is upper specification limit minus lower specification limit divided by 6 sigma, that will give you 1.11 value. Similarly, when you calculate the upper specification limit, CPK, we have to calculate two values. It is upper specification limit minus mean diameter or mean value divided by 3 sigma, and second one takes the left hand side half. So when we apply the values, we will get 1.1. So the minimum of both values are 1.11 and 1.11, we can comfortably take 1.11. So when we compare the previous slides, what is the stability of the process? We can see that the process is just capable. We have calculated the value as so value is 1. So we have calculated value is 1.11. It is just very closer to the CP value, CPK value is 1. So the process is just barely capable. Any point of time there is a possibility that there will be deviation from the central position and the parts produced may go beyond the control limits. So this is how we have to analyze the process, whether it is stable or not. If the process is stable, we have to maintain all the influencing parameters as it is. Suppose if the process is not capable, we have to consider all the parameters and we have to take corrective measures to bring back the process in stable condition. So with this note, let us complete the video lecture related to process capability. So thank you for listening. Thank you.